Here's a graph of the inverse or arc sine of x. You can see that the graph itself is not a function because it doesn't pass the vertical line test. There are multiple y values for given x values. So if we're going to choose a principal branch, we need to look at these 5 criteria. It has to be a function. It must use the entire domain of the inverse trigonometric relation, which in this case, the domain is -1 to 1. And it should be a continuous graph if possible. Okay, we're not going to slice this into multiple sections. And centrally located near the origin. And if there's a choice between 2 possible branches, we're going to use the positive side. Take a moment and see if you can determine the principal branch of the arc sine. Here you can see it highlighted in purple. The range of this function is going to go from -π/2 to π/2, covering the entire domain, centrally located, and continuous. Let's take a look at the arc cosine. Again, the arc cosine is not a function. So let's see if we can take a moment and determine the range and domain of the inverse cosine. First of all, the domain is going to be from -1 to 1. Give it a try. Here you can see that the area we chose was positive, because that was the last option there, near the origin, and covers the entire range and domain necessary. So it goes from 0 to pi between -1 and 1. Let's look at the tangent. A tangent graph has these multiple repeating waves. And if we want to be centrally located near the origin, then we're going to choose, wait for it, that's right, this center branch. Now, the domain for the tangent function is all real numbers. This graph will continue to the left and to the right. The range goes from -π/2 to π/2, not including -π/2 or π/2. Let's look at the cotangent. Again, we have choices. It must be a function, so we're only going to choose one of these waves. It must use the entire domain of the inverse trigonometric relation, which is going to be all real numbers for the cotangent, inverse cotangent. And then centrally located. So here we have 2 graphs that are centrally located. And if it's a choice between 2 possible branches, we'll choose the positive. So we should end up with this positive branch, where the domain is all real numbers and the range is 0 to pi, not including 0 and not including pi. Alright, the graphs of the inverse secant and the inverse cosecant, the primary branches, are a little more interesting. Here, again, it must be a function. So we have these U-shapes, which are not functions. To create a function from the U-shape, we're going to have to slice it in half and pick either the upper or lower half to represent that range of, or that domain of x values. So we need 1/2 from a U-shape on the right side and 1/2 of a U-shape on the left side. Since we want to be positive, not negative, and centrally located, we're going to choose the upper half of this U-shape and the lower half of this U-shape. The domain of our x values goes from -∞ to -1, and then from 1 to +∞. We don't have any x values that generate y values between -1 and 1. Our range is going to go from 0, the bottom of this U-shape, or this half U-shape, up to pi/2, but not include pi/2 because we have an asymptote here, and then from pi/2 up to pi. For the inverse cosecant, again we have the same issue. We have these U-shapes, so we can only choose half of each U-shape. Since the centrally located priority is higher than the positive side priority, we're going to choose half of these U-shapes that are centered around the origin. See if you can picture it. Hopefully this is what you saw. Again, our domain is going to go from negative infinity to negative 1, and 1 to positive infinity. And the range here is going to go from negative pi over 2 to 0, but not including 0 where our asymptote lies, and then from 0 up to pi over 2. So let's summarize. For the inverse sine principal branch, our y values will go from negative pi over 2 to pi over 2, which, if we convert that to a unit circle, negative pi over 2 to pi over 2 covers quadrants 1 and 4, and our domain goes from negative 1 to 1. The inverse cosine principal branch goes from 0 to pi for our range, which would cover quadrants 1 and 2 on the unit circle, and our x domain is negative 1 to 1 inclusive. For the inverse tangent, we go from negative pi over 2 to pi over 2, much like the inverse sine, except we don't include the endpoints where our asymptotes lie. And again, that's quadrants 1 and 4. The domain for x is all real numbers. For the inverse cotangent, we go from 0 to pi inclusive for the range, covering quadrants 1 and 2. And again, the domain is all real numbers. For the inverse secant, we go from 0 to pi for our range, excluding the value y equals pi over 2 where the asymptote lies. And quadrants 1 and 2 are our y range. Here we can simplify our discussion of the domain by saying that the absolute value of x is greater than or equal to 1, which means we go from negative infinity to negative 1 and 1 to infinity. For the inverse cosecant, the range is negative pi over 2 to pi over 2 inclusive, except for the horizontal axis where y equals 0, where we have that asymptote. This covers quadrants 1 and 4 on the unit circle. And again, the domain is the absolute value of x greater than or equal to 1.